have you ever wondered where the wind comes from? Wind is not just a random gust of air, but rather air in motion, a phenomenon born out of the sun's influence on our planet. Picture this: the sun, our solar system's radiant power plant, beams down on Earth, heating its surface unevenly. This uneven heating is key to understanding the birth of wind. In areas where the sun's rays are most intense, the air heats up and becomes lighter, causing it to rise. As this hot air ascends, it leaves behind a void. The cooler, denser air from surrounding areas, eager to maintain balance, rushes in to fill this space. This movement of air from areas of high pressure to areas of low pressure is what we feel as wind. So the next time you feel a breeze against your skin or watch the leaves rustling in the trees, remember it's all down to the sun's heat. Now you might be curious about these terms, high and low pressure areas. What are they exactly? Let's start by imagining the Earth's atmosphere as an ocean of air. Just like water in the ocean, air has weight, and this weight creates pressure. Now, this atmospheric pressure isn't the same everywhere. It fluctuates, creating what we call pressure areas. High-pressure areas are regions where the atmospheric pressure at the surface of the Earth is greater than its surrounding environment. Picture a mountain of air. It's heavy, so it sinks towards the ground, spreading out as it descends. As this air descends, it warms, causing water vapor to evaporate and thus the sky to clear. This results in calm and clear weather that we often enjoy on a sunny afternoon. On the flip side, we have low-pressure areas. These occur where the atmospheric pressure at the surface of the Earth is less than its surrounding environment. Imagine a valley of air. It's lighter, so it rises. As this air rises, it cools, causing water vapor to condense into clouds and potentially rain or snow. This gives us unsettled and stormy weather, the kind that prompts us to keep our umbrellas at arm's reach. So the dance between high and low pressure areas drives our weather patterns, giving us the diversity of climates we experience on Earth. Think of high and low pressure areas as the Earth's way of balancing the scales. Ever wondered why it's hotter at the equator and colder at the poles? It's all about the uneven heating of the Earth. You see, our planet doesn't sit straight up and down in its orbit. Instead, it leans on an axis at a tilt of about 23.5 degrees. This axial tilt, combined with Earth's elliptical orbit around the sun, is the recipe for uneven heating. Now, imagine the sun's rays as a troop of diligent soldiers marching towards the Earth. At the equator, these solar soldiers hit the Earth's surface head-on, pouring their energy most directly. Hence, the equator basks in a greater intensity of sunlight, and as a result, it's warmer. On the flip side, at the poles, these rays strike at a shallow angle. Like a stone skipping across a pond, a lot of the sunlight just glances off the atmosphere. This results in less direct sunlight reaching the poles, making them colder. But this temperature difference doesn't just create an array of climates, it also sets up a fascinating game of pressure tug-of-war, leading to the creation of our global wind system. Warm air at the equator rises, creating a low-pressure area, while the cold air at the poles descends, creating a high-pressure area. And voila, the wind is born, rushing from high to low pressure. So, the sun's uneven heating of our planet not only gives us our diverse climates, but also drives the wind. So, we've learned where the wind comes from, but where does it go? This is where the journey of the wind becomes interesting. Wind isn't just a random gust of air, it's a traveler moving from areas of high pressure to those of low pressure. This journey of the wind is not just a simple trip, it's a vital part of our weather patterns. Imagine the wind as a courier, delivering packages of heat and moisture from one place to another. These deliveries create the weather conditions we experience daily. They might bring a cool breeze on a hot summer day or a warming gust in the cold of winter. Now, let's think bigger. On a global scale, wind patterns help determine the climate zones of our planet. They transport warm air from the tropics to the poles and bring cold air back down, creating a constant dynamic exchange. So, the wind's journey is an essential part of our Earth's complex weather system.